In this video, we're going to do some factoring. We're going to start out the most basic thing. We're going to factor out the greatest common factor. So if we start out, for instance, with 9 plus 81x, well, we look at the two elements here, and first of all, we need to point out that each element is separated by a plus or a minus. So I have two expressions here separated by a plus or minus. So I need to factor out anything that is in common between a 9 and an 81x. So both of these are divisible by 9, so I can pull out a 9. And what's left? Well, that's going to be 1 plus 9x. So let's go back and check our work. So 9 times 1 gives me 9, plus 9 times 9x gives me 81x. So check, we get back to where we started. Let's try another one. So if we tried, say, 45x squared minus 30, what would we get? Well, our greatest common factor is going to be 5, because 5 goes evenly into 45 and 5 goes evenly into 30. So when we pull out our 5, we're looking for what's left. Well, if you're not sure what's left, or you're new to factoring, the best thing might be to take your 45x squared and divide it by the 5 that you've pulled out, minus the 30 divided by the 5 you've pulled out. And that's going to give us 5 times 9x squared minus 6. Now that looks good, except I now notice that, hold on a second, the 9x squared and the 6 have something in common, don't they? They each have 3 in common. So what I should have factored out was I should have factored out a 15. So when I pull out that additional 3, that leaves me 3x squared minus 2. So the solution to the question would be 15 times 3x squared minus 2. Okay, so let's do another one. So let's say that we have something a little bit more difficult, like 27x squared y to the 5th minus 72 x cubed y squared. Okay, so each one of these has a number that is divisible by 9. So we know we can pull out 9. So let's go ahead and write that out here. Each one of these has some x's in there, and we have a pair of x's here, and we have 3 x's here, so the greatest number of x's that we can pull out would be 2. So let's pull out x squared. And then we have some y's, so we have 5 of them on the left and 2 of them on the right, so we can pull out 2. That's the greatest number that we can get out of both. So what are we left with? Well, we're asking ourselves, what times 9 gives us 27? Well, that's going to be 3. So what times x squared gives us x squared? Well, that's 1. We don't need to write times 1. And what do we need to multiply times our y squared to get back to our y to the 5th? Well, that would be y to the 3rd, or y cubed. And we bring down our minus sign. So then 8 times 9 is 72. And we need an x to go with the 2 that we have out here to give us the 3. And y squared goes into y squared once. So our answer is going to be, as you can see, 9x squared y squared times 3y cubed minus 8x. So we're pulling out the greatest common factor. Let's try something a little bit more involved. So let's say that we have 3x plus 12y minus 15x squared y squared. Okay. So when I look at this, I notice that each one of these is divisible by 3. And I notice my first character and my last character have x's, but the middle one does not. So I can't pull out anything involving x's because they don't all have x's. And I can't pull out any y's because only expressions 2 and 3 have y's. So the greatest common factor that I can pull out here is going to be a 3. And that's going to leave me x plus 4y minus 5 x squared y squared. Okay. So let's try something considerably more difficult. So if we had something like 40 x to the 10th minus 20 x to the 12th plus 50 x to the 11th minus 50 x to the 14th. So I notice every one of these characters is divisible by 10. So we can pull a 10 out of everybody. I meant for this to be to the 14th. So how about our x's? Well, every one of these expressions has at least x to the 10th. So let's pull out 10x to the 10th. So when we do that, what's left behind? Well, that's going to give us a 4, because 4 times 10x to the 10th gives us 40x to the 10th. Then minus, how many times does 10 go into 20? It goes in there 2 times. And that's going to give us what? X squared. Then we're going to have 5x minus 5 x to the 4th. Let's try another one. So if we had 30 a to the 8th plus 6a to the 5th plus 27a cubed plus 21a squared. Well, let's see. Everything is divisible by 3. That's the greatest common numerical factor. Well, what's our greatest coefficient factor? Well, every one of these has at least a pair of a's. So let's factor out 3a squared. So what's left behind is going to be 10a to the 6th plus 2a cubed plus 9a plus 7. Okay. Well, let's try one more since we're doing so well. So let's try negative x cubed y to the 6th minus 10x to the 4th times y minus 9y squared plus 9. So what's our greatest common factor here? Well, when we take a look at these expressions, numerically, we are not finding anything that they have in common numerically. Then when we look at the variables, we have a couple of them have x's, and we have 3 of them which have y's, but we don't have anything in common to all of them. So unfortunately, with regard to the greatest common factor, this one is prime. That gives us a quick look at factoring out the greatest common factor.